Now we're launching into measurement and distance. And measurement and distance usually occurs at about end of February, early March. The first skill in measurement and distance is being able to convert between standard American measurements. And so it's not just about the computation, it's about understanding what these things represent. So they'll ask students to convert many things. They'll ask them to convert time, they'll ask them to convert length, weight, volume. The first thing we usually do is just review the different things that we measure. And then we talk about what types of standard units of measure we use. And often kids will get confused what standard measurement compared to metrics, so you really want to make sure you separate those two. And then you just start helping them classify and organize the information. They should be able to classify and organize this information and compare it on a T-chart. So let's say I'm asking them to convert back and forth from inches to yards. So that's going to require two conversions. First, they need to know how many inches are in 1 yard. Well, the step that I skipped here was that there are 12 inches in 1 foot and 3 feet in 1 yard. So they would be doing that in their head, and then you would just ask, well, 1 yard, how many inches would that be? Well, it would be 3 times 12. So that would be 36 inches in 1 yard. And then once they have the basic calculation, they can do the rest. That's a pretty typical conversion they might ask a 4th grader to do. There's just a lot of memorizing with what the different measurements are in standard measurement. The children have read lots of books in kindergarten through 3rd grade about standard measurement, like how big is a foot and why it seems so random, the values, because they are random. They were chosen by leaders of countries, and it wasn't a logical, thoughtful process like metrics is. So they just kind of have to memorize those. They also sometimes get confused about the difference between weight and volume. Weight is how heavy something is. Volume is the amount of space something takes up. Width, depth, height is volume. And the only kinds of volume we measure are square units. That's another thing that's a little confusing for kids. And that's because it's really hard to measure a shape if it's not in square units. They might also get confused by time, especially elapsed time, if they are asked to do a question that deals with elapsed time. And what I usually ask students to do if they're having problems with elapsed time is take a clock and open it up, unfold it, and then use that for the problem. So if I were to say, our school starts at 8:30, we have an assembly at 10:45. How much time until the next assembly? Well, the first thing I would do is have them make a clock, but instead of the clock being in a circle, I would have them take that circle, break it up, and open it flat. So the clock starts at 12, goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And all you would do is put these values on the clock. So 8:30 is right here. How much time is going to pass till 10:45? Well, I know 8:30 to 9:30 is 1 hour. 9:30 to 10:30 is 2 hours. And then 15 minutes. By unspiraling the clock, you make it easier for the kids to see what's really happening. So that's how I do elapsed time. Volume, it's just about making sure they understand what volume is. The only other element of measurement and distance 1 that we need to make sure that we remind students of is the conversion tool that they probably use quite a bit in 3rd grade, which is Mr. Gallon Man. That helps them remember the different measurements. So a good way to remember standard measurements for volume are a gallon is the body of Mr. Gallon Man. Make a smiley face for him. In our own arms, I have a skeleton in the classroom that I show them. The top part of our arms, the bone is just one part. And so it's the same for Mr. Gallon Man. He has 4 parts that equal a gallon, and each of those are quarts. So there are 4 quarts in a gallon. And then the next measurement is pints, and just like our arms and legs, there are 2 bones in the second part of our arm. There's 2 bones in the second part of Mr. Gallon Man. And they can see that there are 8 pints in a gallon, or 2 pints in each quart. The only way Mr. Gallon Man is different than us is that he only has 4 fingers on each hand and 4 toes, and those would be cups. So there are 16 cups in a gallon. I wish they would add tablespoons, which are 3 teaspoons in a tablespoon. If you have a creative way to do that with your students at home, feel free. Because that is or if you can cook with them, that would be wonderful, because they do need the extra practice in these standard units of measure. So reminding them of Mr. Gallon Man helps. And then they have the tools they need to convert. Drawing a picture of it is super, super important. So the next one is measurement and distance 2, which is the dreaded word problems. So we use the same strategies we learned in operations and algebraic thinking of underlining what the different numbers represent, draw a picture of it whenever possible, and make sure you're answering the question that was being asked. So a typical question you might come across might say, Tim bought a train ticket for $16.29. You'll notice I said and that's because a decimal is what you use to say and. $16.29, and he paid with a $20 bill. $20 bill. You might want to instantly subtract. Please don't. Once kids go to computation, they're very unwilling to draw a picture of it. It's better to do the computation later. That way they can use it to prove their answer, not see it as, I'm going to do the work, then I'm going to draw a picture just to appease my teacher. I really want them to do the picture so it solidifies their conceptual understanding. So the question is, how much money did he get back? Well, that's easy to figure out. If you spent $16 and you have $20, again, if I drew it on a number line and I went back 19, 18, 17, that would bring me to $17. And then I know that this distance is cut into 100 parts because that's what our coins are broken into. So what's the difference? How much more do I have to go down to get to 17, 16, 99, 89, 79, 69, 59, 49, 39, 29. So that would be 31 cents. So that would be $3.31. Drawing it on a number line, again, helps them conceptually understand, but I'm not done because in these multi-step word problems, they're always going to ask you a question at the end that is one more step. And you want to make sure that the students make sure they've answered the question that's being asked. So now it asks, using the least amount of coins and bills, what coins and bills should Steve receive? Well, since there's no such thing as a $3 bill, but there is some kids might know there's such a thing as a $2 bill. If they don't, then I would accept 3 ones. And I would have them draw a picture of $1, $1, $1, and then 25-cent piece, 5-cent piece, and a 1-cent piece. And I would have them draw a picture of it. Again, super important that they understand conceptually before they go to computation. Another example that they might give in a word problem would be to use Mr. Gallon Man to convert. So I would probably ask the students to draw Mr. Gallon Man off to the side so that they have the tool for reference if they need it. They don't even need to get that complicated with it. It's pretty simple. Just the G, Q, 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 Q. And then pints. And they don't, at this point, have to write all the P's. They just have to show me they know these are pints. And then cups would be the 4 fingers. 4 here. And 4 here. Now they have him, and if they were to be asked, John made 2.5 gallons of chili, gallon. How many cup servings should he serve? Well, that's perfect for a T-chart. If there are cups, if there are 16 cups in 1 gallon, how many cups should he serve? Well, he has 2 gallons right off the bat. So he knows 16, 1, 32, 2 gallons. And he needs 1/2 gallon, which would be 1/2 of this. And that's 1/2 of 16 is 8. Add that to his 32 cups. 32 cups plus 8 cups is 40 cups. And I would want them to label what each number represented. For MD3, that's using area and perimeter in the real world. They've been taught the concept of area and perimeter in 2nd and 3rd grade. Now they're supposed to use it, really use it in real world applications. So They should understand that perimeter has the word meter in it, which measures length. And peri means distance, the distance around the length. So perimeter is measuring the distance around an object. The biggest challenge they have with area is understanding that area is always measured in square units. And they can either write the words square units, or they can write the exponent squared. And I do front load 5th grade curriculum because they won't learn exponents until 5th grade. But I do explain to them what an exponent squared means. It basically means the same length as width, length and width. And that's because a square has the same length and width. In the real world is, first you give them an opportunity to play with it. So they'll take a number like 16 and they'll say, let's make an object with a perimeter of 16. And in 3rd grade, they did get a lot of practice with that. They would say, how many different rectangles and squares can we make with the perimeter of 16? Well, they know a perfect square is going to be 16. They should also know that they could go 7 and 7 and 1 and 1. And that'll give you a perimeter of 16. And what would the different areas be of these different objects? So giving them an opportunity to play with it is the first step. The next step is, can they identify the perimeter if they have part of the perimeter of a polygon? So if they have an object like this, and I say the perimeter line on this side is 16, and the perimeter line on this is 6. Can you tell me what number is missing? And they should be able to identify that this line then has to be 10. So lots of playing with it and lots of adjusting before we start to deal with word problems. And the same rules of word problems apply to this skill as the other skills we worked on. Label what the numbers represent. Wherever possible, draw a picture of it. Make sure to label your work and make sure to answer the question that's being asked. Also on this skill, they do need to be introduced to the formula for area and perimeter, and they need to be able to represent. So if I show them that the formula for perimeter of any quadrilateral, they'll learn about quadrilaterals when we do geometry shapes, but they've been introduced to this particular one before. The perimeter is length plus width plus width, or 2 times the length plus 2 times the width gives you the perimeter. The formula for area is always length times width gets you the area squared. So if they were dealing with a shape like this, that's pretty easy. But what if they were dealing with a room that had one of the corners cut on it, and the cut represented the shapes? Would they know how to use the square units to analyze what the area is, or would they have to count boxes? What you want to avoid is them counting boxes. So they need to extend their thinking from 3rd grade, where they just counted boxes, to using the formula in 4th grade. And this is just an introduction to formulas, so it's bypassing the individual counting and counting more using multiplication. So they should be able to go 1, 2, 3, 4, 4 horizontally or in rows, and then 1, 2, 3, 4, 4 vertically or in columns, and 4 times 4 is what the area describes, and that would be 16, except this one square is half, so it's 15 and a half squared, square units, okay? Or they could say square units written out in word form. So the next skill is measurement and distance 4. This one's often confusing to parents. They wonder, why is that the one form of organizer for information that fourth graders are expected to use? And if you taught middle school and high school, you'd understand. Stem and leaf plots is a really standard way for organizing information, particularly computer-based information now. And so understanding the concept of a line plot not only helps them with stem and leaf plots later on, but also helps them with bar graphs and histograms, which they also will have to learn in 5th and 6th and 7th grade. So the first thing you really want to teach them about a line plot and how to use it is that we usually list the information that we expect not to change on the bottom. So this is where we list the numbers describing the information. So for example, if I were being asked to list on a line plot the number of pets that children have in a 4th grade classroom, I would probably list, well, they're either going to have 1 pet or 2 pets or 3 pets. And if they have 3 pets, I'm not expecting that to change. So this is the descriptor numbers that I use for the information. I'm not expecting it to change. This is the numbers I'm using to help me organize my information. You might also want to tell him that this is called X, the X-axis, and that's just to help out your future graphing teachers in upper grades so that they never get confused by that. So once you tell them, well, that's the line we're going to use to organize, and they could have more, and they could have none, but this is what we expect them to have, 1 or 2 or 3. So how do you list that information? Well, it's sort of like a tally chart, except the thing you need to make sure they do is write very neatly so that they're organizing their information at a measured level that's the same. So let's say they have 3 students who have 1 pet and 5 students who have 2 and 3 students who have 3. And you want to take the time to make sure they understand that the horizontal level should be level with each other so that the bars represent an accurate amount of information. And this is how it helps them to make bar graphs and histograms later. So now you ask them to read it. Well, you can't because this is not labeled. And this is why it's really important to label what your numbers represent. So you need to write a sentence that says number of pets in 4th grade. Okay? And then you also want to represent what's changed, and Y usually represents what's changed. So what changes? Well, the number of students change. So students students. So there's 1, 2, 3 students with one number of pets in our 4th grade class. 5 students with 2 pets in 4th grade. 3 students with pets in 4th grade. And we're not done. Then you have to be able to solve word problems using it. So if the question said, how many have exactly 3 pets? You would say 3 students. They should also be able to say how many more students have 2 pets than 3. Well, they should know that there are 2 more students that have 2 pets than 3. And being able to create these line plots and use them will help them in science fair, will help them when they do surveys or graphs or any kind of data analysis. It's super important, and it's not enough to be able to just read it in a book. They should be able to create them. The next thing that students are expected to measure the distance on is angles. And this one tends to be a little challenging for them when I first introduce it, because they're used to thinking of angles as an actual object. So most of them know from 3rd grade that this is a right angle. They also can tell me an acute and an obtuse angle. And this is a 90-degree angle. An acute angle is any angle that's less than 90 degrees. Let's say this one was 87 degrees. They would need to be able to tell me that's an acute. And anything larger than 90 degrees is obtuse. Larger than 90 degrees. Okay? Most of the kids know that coming into me, but they haven't had a lot of practice with a protractor, and that's all about protractors this year. So clearly this whiteboard is a little too small for me to use to hold a protractor, so I'm just going to try and draw one for you so you can kind of get a sense of what it looks like in 4th grade to do this one. So I usually introduce this skill by drawing a circle and saying, the first thing we need to do is figure out where the center of this circle were. Well, if we cut out this circle, how would we find the center? Well, what we do is fold it in half exactly, and that would get you the center point. And if we folded it exactly in the opposite direction, that would get you the other line. And then wherever the lines meet, that's the center. And then we do a little bit of review of measurement or of geometry terminology, which we'll do last. That halfway through is called a radius. And this distance from the center of the circle all the way through is called diameter. Diameter. And once we've reviewed that, then I introduce a skateboarder. And I say, what if a skateboarder went to a circular park and he was on his skateboard at the center of the circle and he was facing this direction? And if somebody said, hey, flip your wheels and do a 90-degree turn, most skateboarders know that would mean going from this direction to this direction. And then if he put his board right again, and they said, hey, can you make a 180 turn? He would know that it's the degrees around halfway through a circle is 180 degrees. And at this point, it's a good opportunity to help students differentiate clock terminology with degrees of a circle terminology. A clock goes from 12 to 6, but when we measure circles, we measure them in degrees, and that's what that little circle is right above there. And we measure the distance around in order to rotate. Clocks don't measure rotation, they measure time. So it's a good thing to do to just take a moment and help them switch gears. So then, which direction would the skateboarder be facing? He'd then be facing the opposite direction because he's rotated halfway. And if he were to continue to the next 90 degrees, he would be at 270 degrees. And if he could make a full rotation where he was facing forward, spun one full circle, he would have rotated 360 degrees. And students in 4th grade are more and more familiar with that terminology because of cell phone usage and panoramics. They know that when they're rotating their camera 360 degrees, they've made a full circle of everything around them. So that's another way you can help your child at home understand 360 degrees. So once they understand what a degree is and how to measure it, then we get our protractors. Your child probably has his at home. And he'll have an object and he'll have to tell me how many degrees it is. So the thing about a protractor is they tend to be clear, but even if they're not clear, somewhere marked on them is going to be where they want you to put the center point. And just like with rulers, the biggest difficulty with students is getting them to put their ruler at the exact last tick mark. Not necessarily at the end of the ruler, but the last tick mark where the measurement begins. It's the same with a protractor. They're going to want to put it at the end of the protractor. You want to make sure they're marking the tick mark where the center point is. So let's say they have an angle and it's shaped like this. And they ask the students to mark how many degrees is this angle right here. So the first thing the child's going to have to do is take his protractor and find out where on the protractor, and it usually looks something like this. There's usually a mark either right here, or there's a hollow point. You can put your pencil right here, or it might have it right here, where it tells you where to measure up your protractor to the center point. That's really key, because if they want you to measure it here, then the tick marks around the protractor are probably going to begin right there. If they're going to want you to measure it here, the tick marks are going to be there. That's really important. So let's say he's put his protractor here and he's got it measured up. And the tick mark says, hold it right here. And it's perfect. The other thing a protractor is going to have is kind of like an airplane flying through the air. It's going to have a line, and your child needs to put the line of the protractor on the line he's measuring. Once he has that, then the really tricky part comes in. Because sometimes we're measuring angles from this side over, and sometimes we're measuring angles from this side over. So there's two sets of numbers on your protractor. There's one set of numbers on the inside, and there's another set of numbers on the outside. So your child has to ask, well, which set of numbers should I look at? Well, it depends on your line. If my line is, I'm measuring from the center point this way, then I'm going to look at the inside and the outside and figure out which one starts at 0. Then I'm going to measure up this line to 0. So let's say the outside numbers on this one start with 0, and the inside would say 180. Well, it says 180 because if I were measuring from that side, it would be 180. But my start point is here, so I'm looking at the outside number. And then you just go around the protractor. Now, you also want to use what you learned in 3rd grade. So in 3rd grade, they taught you that 90 degrees is a right angle. So you can help your child check themselves, because if that's about 90 degrees, then you know you're correct. And let's say this angle is, I don't know, 98 degrees. So from 0, a little past 90 degrees to 98 degrees is this angle. But remember, got to make sure that you start at 0, wherever 0 is on the inside or the outside numbers, and got to make sure that you're using your common sense. Let me just use one more example. If the line I were measuring went to here, that's a line that's way bigger than 90 degrees. So if I made the mistake and said the wrong one, started with the wrong one, and let's say I started at 180, then this would probably be about 49 degrees. And that's not possible if this is the line I'm measuring, because that's an obtuse angle, and an obtuse angle is way bigger than 90 degrees, so it can't be 49. Okay, so then after MD5, where they know the parts of a protractor, the center point, the inside-outside measurement, then they're supposed to use them. And when we use our protractors, there's not usually any measurements on the angle we're measuring. So you might have an angle like this. And the first thing you want to talk about is this angle has an end point and 2 rays. This is a ray, not an array. An array is a pattern that you can easily recognize. That's an array. That's not what we're talking about here. What we're talking about here is rays, and that's a line with one end point that can go on forever. And often parents wonder, why are making these shapes so important? Well, they're important because if you want to make any kind of measurement of a circle, it really helps to do this. The example I give in class is we have a tetherball court. And the tetherball court has an end point and it has a line. And often that tetherball, the line on the outside edge of the circle, gets chipped away. So if I know the distance from the center point to the ball, let's say it's 6 feet, and I know that the tetherball is at the center of the court, then I can draw a line. If I want the line to be bigger than getting hit with the ball, then I'm probably going to want a line going out 8 feet. And then the 8-foot jump rope that I attached to a piece of chalk, I can easily draw a circle that will keep everybody safe and not getting hurt. So these kinds of real world applications of rays and lines help. If a student wanted to change his desk from a circle or from a rectangular desk to a circular desk, he could find the center point, then measure the shortest distance to the outside edge, grab a piece of chalk, and draw the biggest circle he could possibly make his desk out of. So if I wanted to make a desk even bigger, a foot bigger, this is where the concept of a ray helps. Because if my ray extends out 1 foot this way, then it would also extend out 1 foot that way, and I would get a circle that is 1 foot larger. So once you've reviewed endpoint and ray, and you're ready to start measuring angles, you make sure wherever the center point is that the protractor's on the line. You make sure that the line on the protractor, just like on the little airplane thing, is exactly measured up on the line. And then you find where your zero is next to the ray. Is your zero on the inside or the outside? If it's on the inside, then you'd measure that to wherever the angle stopped. And even if you had a huge protractor, you could extend that line out and it would still hit at the exact same angle. So let's say this line was not 90, it was 100 degrees. And then the next step will be to maybe ask, well, what if I didn't know that? What if I only knew that the other side was 80 degrees? Then how big must this side be? Well, if I know the entire line is 180 degrees, and I know this one is 80, then that one has to be 100. The last scale in measurement and distance is measuring the sums of angles and also adding up the parts of angles to make a whole angle. So what that might look like is your child might see one angle that looks like this, and that's how we know we're measuring this line, not that one. And let's say that this line angle is 100 degrees. If you knew that this first part was 60 degrees, what would this have to be? And that's simply a matter of saying, well, 60 counting on to get to 100, or the other way you could do it is the difference between 60 and 100, and that would be 40. Okay, so that might be one way you see it. The other way you might see it is word problems, because this is all about real life use of angles. Like we talked about before with the tetherball court, skateboarders use angles all the time to measure how far they're going around and their growth in tricks. Another way we might use it is a lawn sprinkler rotates 40 degrees and then pauses. Then it rotates 35 degrees. So how far is it gone? That's a real life application. Your dog will get wet if you don't know how to measure that angle correctly. So if the sprinkler started at 40 degrees and went from 0 degrees to 40 degrees, then 35 degrees more. So this one is 40. And always remember to put degrees. And then this one is 35 degrees. What would the total degrees be? And it's just a matter of measuring up the two angles. 75 degrees. And so if you were at a right angle from where the sprinkler started, would you get wet? No. You would have 15 degrees of space before you'd get wet. The last way you might see this skill is if you saw a ray and another ray meeting the end point, and this were labeled A, and this had this in the corner. That in measurement is a visual image of a right angle. So if this is a right angle, that means it's 90 degrees. and two right angles make a straight line, rotate from one side to the other. So A must also be 90 degrees. There's just some simple problem solving there to make sure that they understand acute and obtuse measurements and how to problem solve.